When I was in school, I had a really tough history teacher by the name of Mr. Harms. This is kind of where I pulled from this question from. Mr. Harms is a notoriously tough teacher who has given A's to only 8% of his students. Wanting to see if his grading standards have toughened as he's gotten older, students take a random sample of 150 recent students and find that 9 have received an A. Is this enough evidence to suggest that Mr. Harms is giving A's to less of his students overall? Use a significance level, a type 1 error probability. I want to reject a null hypothesis that's actually true only 5% of the time. I don't remember. I want to say like B or an A minus. I forget. This is going to teach you, just because he expected a lot of work in it. He expected more of you than you did of yourself. All right. Step 1. Let's run through some conditions and outline what's been given to us. What is P? What is our benchmark, in other words, that we're going to compare our sample back to? 8%. 8% of students have gotten an A from this teacher. So the Q would be the other 92% that did not. Wanting to see if grading standards have toughened as he's gotten older, students take a random sample of 150 recent students. 150 is what? N is 150. How about P hat? What's our sample proportion? I take a sample, and I want to see if this is evidence to show that his grading standards have toughened a little bit. Sample proportion. What proportion of my sample got an A? 9 of. Let's check some conditions here. Was this a random sample?
Yes, sir.
Got it. Is 150 students less than 10% of all his students?
Yes.
Let's assume that he's been teaching for several years. I probably have about 120 students every year. 150 would probably be less than 10% overall, all the students they've had in his career. What's the last one? The last condition to check. It's called the success failure condition. What do we need to know? Is both more than 10. I have to expect 10 students in my sample to have gotten an A, and 10 students in my sample to have not gotten an A. What are the expected counts? So N times P would be 150 times 8%. N times Q is 150 times 92%. This one might be close. What's 8%, not 80%? Oh, yeah. What's 8% of 150? Well, 1% is 1.5, so I have that 8 times. Well, it's close, but it's still more than 10. Yeah, so we'd expect 12 students to have gotten an A, and the other 138 to have not gotten an A. Both more than 10. Counts are good to go. That last one just checks to make sure you have a representative sample. You need to have some that have and have not succeeded and failed. Step 2 is the hypotheses. Take a minute. Write your hypotheses down. Let's see what you got. The ho and the ha. This is a very important step because it outlines how we're going to conduct the remaining steps in our hypothesis. Take a second, write down what you think the null and alternative would be. The null hypothesis is that there is no difference. The alternative hypothesis is that it has changed somehow. It's grown, lessened, or just changed from in general. Gotten bigger, gotten smaller, or just changed from in general. We're talking about proportions, so we're obviously going to put this in terms of the population parameter P. We're trying to show something about the population. We're trying to see if our sample is evidence of something new about the population. What would P be equal to for our null hypothesis? What do we say about the first hypothesis? P would still be equal to what? Taking count? Yeah. Assume that there has been no change. Mr. Harms is still giving an A to only 8% of his students. What else? What about the alternative? What are we trying to show based off of our sample data? Less. So P would be what for our alternative? Less than 8%. That's not trivial. That's going to impact a lot of how we go forward for the rest of our hypothesis test. If I have a 1 or 2 tail hypothesis test. 1, which tail, left or right? Why left? Less than, right? We're going to try and calculate a test statistic that is less than some critical score here in a second. Let's define that rejection region to compare our test statistic back to. Since we know it's a one-tailed hypothesis test at the 5% significance level, I can look up this critical z-score on my formula. We're going to put all 5% error. I want to reject the true null hypothesis only 5% of the time, so let's put it in the left tail, like you said. What is that z-score? Pull up my formula sheet up on the screen. What do you see? Some critical values for hypothesis tests on the board. What do we got? Down 1645, but since it's the left tail, it'd actually be what? Negative 1645. 5% error level will be in row 2. The first column is all the one-tailed z-scores, so I see 1645. Plus or minus 1.645 will cut off 5% on the tail. Since the left tail will do negative. Part 4 is the test statistic. So since you have your formula sheet out, over to the back. We're looking at one sample proportions. I take one sample, I record the proportion p hat, and I want to compare it back to the original population. So here is our test statistic. To do so, the difference in the two proportions divided by the standard deviation, pq times square root of p times q over n to convert it back to a z. Got all that information written down over there. So 9 out of 150 minus 8% divided by the square root of 8% times 92% over 150. Try typing that into your calculator. See what we get. At about negative 0.90. See if you can match what I have up on the television. On your calculator, do we get anything different than this? You're typing the z-score formula into your calculator. I got about negative 0.9. Get anything different? There's two ways to come to a decision about this question. One of them is to compare this test statistic back to our rejection region. Where would negative 0.9 fall within this graph? Is it more extreme? Is it further from 0 than negative 1.645? Would it be in the tail or in the other part of our distribution? Be a little bit like right there, wouldn't it? It's closer to 0. It's less negative than negative 1.645. So do we have evidence to say that Mr. Harms is giving A's to less students? Do we reject the null hypothesis based off of this information so far? But I put my blue mark in the rejection region. No, so are we going to reject? No, we're going to fail to reject. So one way to come to a decision is to compare your test statistic back to this critical z-score. It's critical because it tells you your decision. If I got a z-score test statistic that's more negative than this, reject. Since we didn't, you failed. The only way to do it, to come to a decision, is in the next step by calculating the p-value. On your z-table, we're going to look up the probability of finding a z-score of negative 0.9 or more extreme than that. Which tail do I want? Do I want the left tail or the right tail to look up on my z-table? I look up the left tail or the right tail? I already made this decision. Left. Why left? That's less than. I want negative 0.9 or further into the tail, more extreme than that. So on z-table, negative 0.9 is about 1841. The p-value is the probability of finding our sample data or data more extreme if the null hypothesis was true. I don't actually know if 8% of students are still getting A's from Mr. Harms. That's kind of unknowable. But if that were true, I take a sample such as mine about 18% of the time. If this was actually true, the probability of finding my sample data is about 18%. So if I reject the null hypothesis, wouldn't it be true about 18% of the time, according to my data? With what percent do I want to reject a true null hypothesis? With what percent do I want to make that type of type 1 error? 5%. Is this within my allotted error probability? Is my p-value bigger or smaller than alpha? Bigger. If the p is low, reject the hoe. If my p-value is bigger than alpha, what's our decision going to be? Fail to reject. I only want to reject the true null hypothesis 5% of the time. This isn't within that allotment. It's bigger than that, 18%. So we have to fail to reject, just like we failed to reject based off of this argument over here. I want you to know how to do both. I want you to look up the critical score and use a p-value. So that's kind of why I include both parts in the full hypothesis test. All right, so like we said, what's our decision again? Fail to reject. Sorry. Now, how do we frame our conclusion? Do we find the defendant guilty or not guilty? Not guilty. Why would we define the defendant not guilty in a court of law? Failed to reject because we didn't have enough evidence to say otherwise, right? You're innocent until proven guilty. So the prosecution didn't do their job well enough. They didn't present enough evidence. The jury could be convinced that they were guilty rather than guilty. So to frame our conclusion, we lack enough evidence to show Mr. Harms is giving less than 8% of his students an A. What I don't want you to write is this. Mr. Harms is still giving 8% of his students an A. I don't know that for certain. That'd be like the jury coming back and saying, we find the defendant innocent. Well, no, that's not how that works. We just lack evidence to show otherwise. Any difference between P and P hat, any difference between our sample proportion and population proportion, is just due to normal random sampling variability. Not enough evidence to say that there is a difference between grading policies, Mr. Harms, and what he's doing now. Any difference between the population and sample proportion is just accounted for by random sampling variability. All right, just some good review on hypothesis tests. Question there.